This is an Excel AS C1 video for the revision for Wednesday's exam, or whatever C1 you're doing. This particular video, I've got a load of length formulas and midpoints and gradient formulas behind me. This pen doesn't work. No, bin. Right, sorry. So as I was saying, this video is on not what's behind me. That was from a previous video, but it might be useful in the next video, so I'm going to keep it up there so I don't have to rewrite it. This video is on surds and indices, and just surds and indices. I've done it this way round because these topics are so short, it's pointless me creating a separate video for each of them because it'd be about 5 seconds long. The one after this video, it's going to take a bit of time. It's called quadratics, and we'll be talking about things that I mentioned in that video. But for the moment, we're doing surds and indices. Now, surds and indices, there's a couple of rules you need to know for both of them. We'll start with surds. So what they may ask you is, we were doing a length formula in the trigonometry video. Now, I used a calculator, just a basic scientific calculator here. I mentioned in that video, you're not allowed a calculator in the C1 exam for Excel. I'm not sure about other exam boards 100%. But the main message that I'm trying to get across here is that you use something called surds, which is what the calculator does. It does it itself. It works it out and it simplifies it for you. That's why sometimes you get an answer when you say, I think it was root 200 I did, and I got 10 root 2. I don't know if you can see that. Yeah, it's a little thing that says 10 root 2. Now what the calculator's done is it said, it's picked a square number and it's picked a number that isn't a square number, and simplified it. And if you press S to D, it changes it from a surd to a decimal. That's what S to D means. Just a bit of background on, I've got the Casio FX83 GT, just a basic scientific calculator that is most common in maths exams, and they generally ask you about using that for different modes. Anyway, so if you haven't got that calculator, don't worry about the S to D bit, just worry about knowing surds. So as I said in that little introduction to this video, what the calculator does is it picks a square number and a non-square number. Now what you may be asking me, Will, is, I know some of you probably already know, but what is a square number? It's not one that looks like a square, obviously, but what does it mean? Well, a square number is something you can square root to get a figure. So for example, I'm not going to list these in order at all, but the order of the ones that you probably know straight off your head. So the square root of 9 is 3, because 3 times 3 is 9. So you have to square 9 to get 3. The square root of 16 is 4. The square root of 25 is 5. And the square root of 36 is 6. And the square root of 49 is 7. So they're just a few square numbers there. So as you can see, they are square roots and they equal a number which isn't a square root. Now what we do is we don't pick just a square number and know what this number is going to be. If we've got root 200, for example, what we do is we say, right, so imagine the roots aren't there. What two numbers times to make 100? And one of them has to be a square number, like which demonstrated there. So 200, so root 200 is one I'll pick. So root 200, we use a square number, which you can square root, and a normal number. So what two numbers can we pick to do this? Well, we could pick root 25 and root 4. Is what does, just see what my calculator says when I put it in, the root 200. I'm sure it won't say that. Yeah, it says 10 root 2, which we did before. And the reason it doesn't say 25, root 25 times root 4, is purely because what it would give us is root 25 is 5, and root 4 is 2. So it just gives us these two numbers, which isn't accurate for this. Because what we need is a square number and a non-square number. So a square number could be 100. So square 100 times, you'd square root 2. Because 200 is equal to 2 times 100, and that gives you 200. So you have to do a square number and a non-square number times together to equal the square number of a of the question it's asking you to simplify. Now it may not say specifically simplify root 200. You may get an answer when we're calculating length like we did before, and it says simplify it, leave it as a surd. So that's one thing you might get asked. Hopefully that sort of clarified it. So remember, just to go over that again, so if you've got root 200, you think, well, ignore the root is there, obviously don't just rub it off, but ignore the root in your head, but keep the root sign there, and say, right, what two numbers times to make 200, and one of them has to be a square number. Now for C1, because it's a non-calculator, they're not going to get you to do something ridiculously stupid like root 7,650, for example. They're not going to get, it's something going to be simple like root 200, which we did before. You can do straight off your head like that. So what I was saying there is we could use it for length. Sometimes, what another way they do. So hopefully that's cleared it up. I don't really want to go into any more detail than that because it's quite a simple technique that, and it's more GCSE topic. The sort of thing you might get here is, again, it's the higher end GCSE, but start of A level. What we get sometimes in C1 is the first question on many C1 or EdXL C1 papers, and even AQA C1 papers, is something called where we get a not necessarily a surd on top, but the main thing we're concerned about is a surd on the bottom. So that's times it's a 2, and then on the bottom we might have 2 take, no actually that's a bad example, 8 take 3 root 5, and it says, Rash, make this, simplify this. Now what we do is we times it by 1. Now we don't just simply times it by the number 1, otherwise we'd end up with the same thing, and that's not simplifying it. And we can't divide 2 by 8 because it's, well we could, and we could divide 2 by 3, but what we need to do is get rid of this surd on the bottom. So what we do is we rationalise the denominator. Now I said we have to times it by 1, but if we times it by 2 over 8 take root 3 root 5, we're going to end up pretty much the same thing with the surd on the bottom. It's going to sort of give us the same answer. So we need to transfer this surd on the bottom to the surd on the top to get it on the top. So we do that by timesing it by, if this is 8 take 3 root 5, we times it by 8 plus 3 root 5. So we change the sign in front of the surd. So we do it both top and bottom, because if you times 8 plus root 5, so 8 plus 3 root 5 over 8 plus 3 root 5, that gives you 1. So it's essentially times it by 1. But by times it by the negative, the opposite sign of what is in front of the surd, we're effectively getting rid of it on the bottom. But we still times it by 1, so it satisfies all our rules that we need to obey. So 8 plus 3 root 5. Now the key thing here is put it in brackets, because you don't just want to times 8 times 8 and then 8 times minus 3 root 5 and leave out the plus 3 root 5 bit, because you'd still end up with a surd on the bottom. So you need to put it in brackets. Now sometimes you get a surd on the top and on the bottom, and you just do the same thing, but I'm making it simple, by just leaving a surd on the bottom. So you'd use this formula for any surds where you get it on the bottom. Generally, it's on the first paper, and it says the first question, and it says simplify this, which you should be getting full marks on this part if you want to get your A's and B's. So you're 8 plus 3 root 5. I wasn't taught this at GCSE, by the way. So first time, I just give you a bit of background, I was in set 6 at GCSE. So I wasn't exactly in the perfect set. Because, you know, just to give you a bit of background again, no one really believed that I could do maths. Even just, actually, yeah, my maths teacher said to me, you're not going to be able to do A-level maths when I'm actually teaching people it. So, if I can do this, I mean, a surds is quite simple. You can do this, so don't be put off if you get surds in the top and the bottom. So anyway, we expand these brackets out. So I said, if you've got 8, take 3 root 5, you times by 8 plus 3 root 5. You just simply change the plus, the sign in front of the surd. So times out the top, so that's 2 times 8 is 16. 16 plus 2 times 3 root 5 is 6 root 5. So what we've ended up with is a surd on the top. And if you times 8 by 8, you get 64 on the bottom. And now 8 times negative 3 root 5 is going to cancel out with 8 plus 3 root 5. So that cancels out. So 8 times 8 is 64. And then all we do is we times 3 root 5 by 3 root 5. And obviously one of them is negative. So when you times the root 5 by root 5, you get 5. You just try that in your calculator if you want. So what it essentially becomes is positive 3 times negative 3 and then times it by 5. So 9 times 5, you could do that as a compilation on your surd. So if we take negative 3 root 5 and we times it by positive 3 root 5, sorry, we get minus 45, so that'll take away 45. So if we times 9 by 5, which is the way I said, we get negative 45 as we did for this. So that proves that root 5 times 5 is, root to 5 times root 5 is just 5. So that's what we can do, and we can simplify that if you wanted to. But that's essentially surds covered. So I'll just leave you with that sort of to just have a look at there. So all we do then is simplify this little bit here on the board, but seeing as I'm expecting you can simplify numbers, just simply put them in and divide them, but I'm not going to waste my time trying to figure that one out, purely because I'll probably end up getting it wrong anyway. So that's what you do there. Now hopefully rationalising the denominator doesn't seem that tricky, just a little bit to get your head around there. Again, you can put surds on the top and the bottom, but as long as you follow the formula of times them by the opposite sign in front of the surd, you should be okay on any surd question. The most tricky thing is probably trying to find a square number, you know, to times a non-square number by to get the so you know when we were starting about the start of the surd video, when we said root 200 equals what times what, and you just got to think of that square root number, and just getting your head around that is just maybe a bit tricky. Maybe the mathematics is not tricky, but actually thinking of it, it's very easy saying it now, but when you sat in the example, it's a different story. So that's how we start that question there. So the next part we're going to do is we're going to talk about the indices part of this course. Now the indices is basically when you've got a power. So I'll jump straight in there. Hopefully you should know. There's a couple of rules, I just read them out to you now. You should know, I'm going to write them on the board behind me. Again, if you're in my class and you're using this booklet, the original C1 booklet, it's page 1, 2, 3, 4, 5, 6, it's page 7. Sorry, I don't have page numbers on mine. Topic is obviously worksheet 4, indices. So we're starting indices. Now there's a couple of rules you should know. When you times in indices by, so like 3 to the power 5 times 3 to the power 2, you add the powers, the 5 and the 2, so that's 3 to the power 7 for that one. However, when it's in brackets, you times the indices, so it's 3 to the power 5 squared, 5 times 2 is 10, so it's 3 to the power 10. But when you times it on its own, you just add the indices, but when you squaring it or cubing it, you times the powers. And when you're dividing it, you take away the powers. So 3 to the power 10, take 3 to the power 7 is 3 to the power 10 over 3 to the power 7 is 3 to the power 3, because 10 takes 7 is 3. 8 times, so yeah, so if you've got 3, sorry, you've got, say in brackets, you've got 2 times 4 is 8, and then to the power x, so yeah, so 2 times 4, 8 to the power 2, so 2 times 4 times 2 times 4, 8 squared is 64. It's the same as 2 squared times 4 squared. It's going to give you 64 if I've done that in my head right. As I said, I'm doing these off the top of my head, so may get a few mixed calculations here. But they're the 4 rules you should know, basically adding and dividing, timesing and taking away your indices. Adding them, sorry. Yeah, so there's just a few more. Obviously, these are the kind of rules now you need to know for A-level maths. These rules are kind of common, really. They're not going to give you too many you don't know, and you should be able to just work them out just by going off your head. So if you've got 3 to the minus 1, that's the same as 1 over 3. Because 3 to the minus 1, you say 1 over 3. So that's that one. However, if you've got 1 over 3, no, that's a bad example. If you've got 2 over 8, for example, and you say that's the power of minus 1, you don't flip the sign, you flip the fraction, so that becomes 8 over 2 to the power of positive 1. And obviously that's just 8 over 2. So hopefully that's sort of got you a few rules there. And anything to the power 0 is 1, you should know that. This other rule here, I'm going to, so that index rule here, where it said if you've got minus 1, you flip the fraction over. And if you've got minus 2, you flip it and then square both top and bottom. Now what I'm going to do is include this other rule here that I'm going to show you now. I'm going to include it in that rule we've just sort of figured there. So you might get something like, the general question is you get 16 to the power 3 over 2. Now the bottom power, so the fraction there, the bottom number 2 is the root. So this is the square root of 16. Bear in mind this is a non-calculated paper, so you should be able to do these off the top of your head. They're not going to ask you, say if you've got 3 over 2, they're not generally not going to ask you for the cube root of 16. Even though you could do it, it is 2, by the way, but generally they'd ask you for the square root, so that's 4. And then what we've done is we've done the bottom bit, so we've divided it by 2 with the power, not divided by 2, it's really bad. What I mean is they've square rooted it, and the 3 is the power, so 4 to the power 3. 4 to the power 3, off the top of my head, is 64. I think that's right. Just check on my calculator. I'd be astonished if I'm right, because that was quite quick. 4 cubed. Again, I've done these many times, so if it's right, yeah, it is. That is 64. Wow. 4 times, so I can do that in my head. So it's only because I've just done this so many times, not this question in particular, but just this style. And having done so many past papers, I can tell you across the board they are vaguely all like that. Now what we know is, we know that thing where we said if it's minus 1 of a fraction, you flip the fraction, so it's 3 over 2 to the power of minus 1, it becomes 2 over 3 to the power of 1, you change the sign in front of the power. Now what we've just known there is we said 16 to the power 3 over 2, you square root it and then you times it, you do the power, so it's cubed. Now if we mix them two together, this is likely something you'll see on the exam. Again, this, I don't think there's any more necessarily than that. Might be 1 or 2. No, that was all the rules you need to know. This is the hardest question, kind of question you might get on the exam for C1 for indices. So I'll just zoom it in so you can see it. So what we know now is we know when it's a fraction, all power, you divide, you root it by the number underneath, and you put it to the power of the number on top. And if it's in a fraction and it's minus, you flip the fraction, not the sign, not the power. So let's say this is, we'll do a nice and easy one of 9 over 16, and now we say that's to the power, all of that is to the power of minus 3 over 2. So normally, if you did that, sorry, yeah, my head's massive. Normally, if you looked at that without knowing these rules, you'd go, right, how the heck do I do that out of my head? Because we don't have a calculator for C1, so how are they going to expect us? Now, we said there, it's minus, you flip the sign. So the first thing we see is minus, so we flip it. Even without worrying about the actual power, it could be 16,000 over 2. But as when we see that minus, as soon as you see that minus, we know to flip the fraction. And even without worrying, if we didn't know that second rule of the bottom number is the root and the top number is the power, you get a mark for flipping the fraction. Knowing you flip the fraction, not the power. So that becomes 16 over 9. Now I picked these two square numbers because this becomes positive 3 over 2. And we said the bottom number is the root and the top number is the power. So if we square 16 over 9, that becomes square root of 16 is 4, square root of 9 is 3, that becomes 4 over 3. Now we haven't finished because we've not done the 3, so we cube that fraction, so we cube 4, which we know is 64, we cube 3, which is 27, and that gets us our value there. So that's your answer. Now I haven't done that on the calculator. All I've done is use the fractional powers of indices to work that out. So I think you'd have to admit, if you didn't know that I used them rules, you'd go, wow, he's quite intelligent, he's just done that off the top of his head. And obviously we could simplify that fraction, you know, if we could, but I'm not sure how you do that. Unless I'm missing something out, which I don't think I am. So yeah, so if you don't believe me, that's how we've got that. Just type that in your calculator there, and if you do it, you should get that answer there. But what we've done, the first rule we've done is flip the power. I can't believe I just said that. That's why I've been having people. No, don't flip the power. Flip the fraction. So I've actually done this the most confusing way I could possibly do it. This is why it's one of the hardest questions. Even I get stumped sometimes. So what we do is this fraction here. So this is a fraction. That up there is the power. So we flip this, so the 16 goes in there and the 9 goes in the bottom, because that's a negative up there. If that was a positive, we wouldn't bother with this bit. But because it's a negative, we flip the fraction. So there we go, we get 16 over 9. And the bottom power is the root and the top power is the power. Yeah, the top number is the power. So we square root it. I should have put 2 there, but yeah, it doesn't matter. If that was a 3 underneath, then we would have cubed it, which we actually could have done. And then we use the top power, the top number, which is 3, as a power. So we 4 over 3 to the power of 3. So we cube the top, cube the bottom, cube the top. 4 times 4 times 4 is 64. 3 times 3 times 3 is 27. And that's how we've sorted that answer out. As I said, that's probably one of the hardest using rules. So you might be asked to use a couple of them. And I'd say that's the hardest question you're going to get on the topic of indices. Now hopefully that's been helpful. Not 100% sure if there's definitely going to be an indice question. I'm not sure if it's going to be that tough. It might just simply be as easy as 16 to the power of 3 over 2. As I said, this is a non-calculator paper, so they're not going to ask you something ridiculous. So if you end up with a number you can't work out, either you're doing it wrong, or then it's just you're not thinking straight and you're missing something out. That's obvious. So I know that's easier said than done, obviously, but hopefully that's been helpful, and we'll see you in the next video, which is quadratics.